Good morning to all. Today we are going to discuss about the topic of special electrical machines. So in that, if you see, the fundamental principle of the electrical machine involves in the rotation or circular motion. So the electromagnetic torque producing a rotary motion, then it is called rotating electrical machines. So already we are using in all kind of industries, we are using the rotating electrical machines. For example, agricultural industries, and also the several industries we are going to use in the lift system, and also in our own home appliances we are using the rotating electrical machines. But in large industries where we have to transport the material from one side to the other side, where the human being cannot enter, then we require the conveyors to transport the material. Similarly, in the railway application also, where the research is going in the bullet train and all, we need the motor should be operated in the linear motion. So the electromagnetic force which producing a linear motion in a machine, then it is called linear electrical machines. So in the linear electrical machine, we are going to have three types. One is called linear induction motor, then linear synchronous motor, and then DC commutator linear motor. These are the three types of the linear electrical machine. So by requiring the application of the high speed ground transportation and the conveyors and the sliding doors, the curtain pullers, we are going to make use of the motors to be operated in the linear motion. Hence, the researchers making the extensive research in the area of propulsion to lead to the development of the linear motors. So the principle of the linear motor, what they found is, so whenever a relative motion occurs between the field and the short film conductor, that is the short circuited conductor, then the current is induced in them. So under the influence of this current, the electromagnetic force will be developed. So the electromagnetic forces tend to move the conductor in a way it has to eliminate this induced currents. So in this way, it is similar to the principle of the induction, that is the general purpose motor. Here what we are going to do is, the principle will be what we are going to, the circular motor has to be cut and it has to be made flat. So what happens here, the electromagnetic flux created will be, it is developed entire surface in the straight line motion. So when the induction motor is cut and laid flat, then we are obtaining the linear induction motor. So in that, the linear induction motor, if you see the construction, so here the general purpose motor which is going to have the rotor and the stator over the rotor has to be cut and it is laid flat as shown here. The stator will be considered as the primary winding of the linear induction motor and the rotor is considered to be the secondary of the linear induction motor. So here, due to the principle what I explained, we are going to have the current will be induced in this and thereby we are going to develop the electromagnetic force which is going to tend to move the conductor in a such a way it has to eliminate the current induced current. Okay. So what happens, the field as well as the conductor both will be move in linear motion. Both the stator and the rotor, that is here the primary and secondary, that is the field and the conductor will move in the linear motion as a straight line. So usually the primary of the linear induction motor is going to be a magnetic core with the three-phase winding, and the secondary is just a metal sheet or three-phase winding wound around the magnetic core can be the secondary of the linear induction motor. So here in the linear induction motor, the parameters what in the as per the general purpose motor, we are going to have the angular velocity and the torque will be developed as the parameter. Whereas in the linear induction motor, here we are going to have the thrust, or it may be called as a force will be developed, and then the linear velocity will be the other parameter what we are going to obtain from the linear induction motor. So in order to maintain the constant force over the entire surface, we are going to make the one side will be shorter than the other side. For example, in the railway application and all, so we are going to have the primary will be the shorter and the secondary will be the longer. So that means the integral part of the vehicle will be assumed to be a primary and the track will be assumed to be secondary of the system. So in that way, so now the bullet trains will be operated by using the same principle of the linear induction motor. So coming to the types of the linear induction motor, we are going to have two types. One is called single-sided linear induction motor. Here in the single-sided linear induction motor as shown here, so this will be called as the primary of the linear induction motor, and then we are going to have the secondary conductor which is going to be laid here. So whenever you are having the one primary winding and one secondary conductor, then it is said to be a single-sided linear induction motor. Then the other type will be the double-sided linear induction motor. So here, as shown in this diagram, the top one will be the primary winding of the linear induction motor, and the bottom one is also a primary winding of the linear induction motor. In between these two, we are going to have the secondary conductor which will be formed in between these two primary winding. So hence, we are going to have the two types of linear induction motor. One is the single-sided, other one is the double-sided. So coming to the operation of the linear induction motor, when you supply a voltage to the primary of the linear induction motor, then the magnetic force, that means by inducing current, the magnetic force will be developed on the primary, which is going to be induced on the secondary of the conductor. So when the primary is stationary, then the secondary conductor will be move in the same direction of the magnetic force. In the other way around, if the secondary is fixed, then the primary tends to allow to move, then the force will be, that is the primary will be moved in the opposite direction of the magnetic force. So that will be takes place when the primary is allowed to move, it is going to move opposite to the magnetic force. In this way, the linear induction motor will be using the operation, either it can be primary can be fixed and secondary along the same direction. The other way around, the primary is allowed to move in the opposite direction, the secondary side is stationary. In this way, you can operate either primary or secondary. Then, coming to the characteristics of the linear induction motor, here we are going to draw between the velocity and the thrust, or it may be called as a force. So here we are taking in y-axis the velocity will be drawn, and in x-axis thrust will be drawn. So if you see here, when the thrust or force is 0, the velocity will be reaching maximum. So when you increase this force step by step, you can observe that the velocity is considerably going to be decreases, and at one stage the force is maximum, the velocity will become 0. So in this way, the characteristics will be developed for the linear induction motor. So by having the operating principle and the characteristics of the linear induction motor, we are going to have the several applications. That is the high speed ground transportation, and we are going to have the conveyors also using the same principle, and the electromagnetic pumps, and also the trolley cars, and then metallic belt conveyors. All these are using the principle of the linear induction motor. So in high speed ground transportation, we are going to have the railway application will be takes place by using the high speed ground transportation. So as I said here, that the integral part of the vehicle will be said to be a primary, and then the track will be considered as the secondary. So the track will be stationary here, the primary will be moving. So that principle will be used in the bullet train application of our country. Then the conveyors. So we are going to have the conveyors will be used in large number of industrial applications where the material has to be transported from one side to the other side. Even our airport system and all, we are going to use the trolley conveyors where we are going to keep our luggage, and it has to be received in the receiving end. It travels over a considerable distance. We can take our luggages and we can use this conveyor application. Similarly, we are going to use the moving steps. In also the moving steps also we are going to use the linear induction motor, where here that moving steps and all we are going to have the secondary will be moving, whereas the primary will be held constant. So that concept will be used in the linear induction motor, where the conveyors and then belt conveyors all will be using this linear induction motor.